Hello. So in this video, what we're going to look at is calculating the equation of a plane. So a plane is a flat two-dimensional surface, and we can define the general equation of a plane, which we use the lowercase pi letter to represent what a plane is given by ax plus by plus cz equals d, and this is called the Cartesian equation, or the Cartesian form of a plane, where ABC is a vector normal to the plane. A normal vector to something is a vector that's perpendicular, and d is just going to be a constant, a value. Okay? There's a clear method to calculating this, depending on how much information you've been given. So if you've been given 3 points on the plane, the first thing you're going to need to do is calculate two non-parallel lines on the plane, which we just do by calculating two vectors, so vector AC and AB, for example. From that, we can calculate a vector normal to the plane. We know how to do that because of what we've learned already about cross product, because that will allow us to find a vector perpendicular to both of these, which is going to be a vector normal to the plane, and then from that we can just substitute the normal vector into A, B and C, and using another point on the line on the plane, we can calculate the equation of the plane. So depending on how much information you've been given, so the easiest way would be if you're simply given the normal vector at a point on the plane, then it's really straightforward, it's just subbing in. But the most you could have to do is if you're given, like I've done here, 3 points on the plane, and then we just work our way through it. So, first thing we're going to have to do is calculate two vectors. So that's straightforward. AB is just going to be B minus A. So 1 take away 2 is negative 1. 2 take away 1 is 1. 7 take away 9 is negative 2. And then we also want vector AC. Doesn't matter really which two you go for. So AC is going to be minus 3 minus 2, which gives us negative 5. 7 minus 1, which gives us 6. And 1 minus 9, which gives us negative 8. Okay? So now I've got two vectors on the plane. What I now need to do is calculate the normal. And I'm going to be able to do that by using our cross product of the two vectors we've just found. Okay? So then breaking that down, we get I, 1, negative 2, 6, negative 8, minus j, negative 1, negative 2, negative 5, negative 8, plus k, negative 1, 1, negative 5, 6. Okay, and then we can calculate that. 1 times negative 8 is negative 8, minus negative 2 times 6 is negative 12, minus j. Negative 1 times negative 8 is 8, minus negative 2 times negative 5 is 10, plus k. Negative 1 times 6 is negative 6, minus 1 times negative 5 is negative 5, giving us finally negative 8 minus negative 12 is negative 8 plus 12, which is going to give us 4. 8 minus 10 is negative 2. Negative 2 times negative j gives us plus 2j. Negative 6 minus negative 5 gives negative 6 plus 5, so we get negative k. So our normal to the plane is 4i plus 2j minus k. Therefore the plane is going to equal ax plus by plus cz. So it's going to be 4x plus 2y minus z equals d. And now all we need to do to calculate d is substitute in one of the points that we know is on the plane. So I'm going to use point A. I'll sub that in. So we're going to get 4 times 2 plus 2 times 1 minus 9 equals d. So we get 8 plus 2 minus 9 equals d. 8 plus 2 is 10. 10 minus 9 is 1. So d equals 1. And so the equation of the plane is 4x plus 2y minus z equals 1. That's how you find the equation of a plane.